Good afternoon, everyone. Today's just going to be a quick little video about how we actually use the trig ratios. So a very simple one, very quick one to begin with. So every angle has its own unique value for sine, cosine, and tangent. All right, so for example, if you put sine 27 into a calculator, it would give you some really long and horrible number, but to 3 decimal places, it would be 0.454. So this means that in any right angle triangle where there is a 27-degree angle, the opposite and hypotenuse, those sides would be in this ratio. All right, so example, if you look at a couple, that's a 27-degree triangle. The opposite side here is 20. The hypotenuse is 44.72. And if you wanted to calculate it, hopefully 20 divided by 44.72 would be equal to the 0.454. Okay, might not be perfect because of rounding in here and in here, but it should be very close to that number. And if you did with another one, okay, so this time still 27 degrees, but this time 30 here, 67.08 here. If you were to do 30 divided by 67.08, hopefully it comes out as 0.454. And that should be kind of obvious to you, I hope, because these two triangles, they are similar. Okay, all the angles are equal. So all the matching sides should always be in the same ratio. Okay, that's kind of where the whole basis of trigonometry comes from. Right, everything's in the same ratio because they're always similar triangles. And then sine, cosine, tan, they're just fancy names. So let's look at how we actually get these values. So usually in my world, I've always used a calculator. Okay, just a nice simple scientific calculator, but we don't get to use the calculator here. So just like my grandfather used to do, you get to use a table of values. So this table, I'm going to put it on the Cub Plus website later on. It has all of the values of all of the angles between 1 and 89. Okay, so all the possible whole number angles you could get in a right angle triangle. All right, so you need to be able to read this table and use it to find missing sides. Okay, so look at a couple of examples. So first we have one here. We have a 48-degree angle. We have one side is A, another side is 10. We want to find the missing one. So to do that, from the angle here, we work out what sides we've got. So the one we want to find is straight across, so it's the opposite. The one we know, that's the hypotenuse. So we're going to use sine, right? Sine was opposite over hypotenuse. So work it out using the table. So if you looked at that table, you would have gone to 48 degrees and found sine is 0.743. So next, to find the missing side, we know that sine of 48 degrees, okay, the angle here, is equal to the opposite side, so opposite, which is A, over the hypotenuse, 10. Okay, so sine 48 is A over 10. Now sine 48, it is actually just a number. Not a nice number, but a number. So sine 48 is 0.743, which is equal to A over 10. Multiply both sides by 10, A is 7.43. Okay, so we get an actual value for that missing side. We'll do the same thing in the next one. So again, you have right angle triangle, you have one side is E, we want to find the missing side, and we have another side which is 20. So first, figure out what sides you've got. So from the angle here, this one straight across would be opposite. There's nothing there, so that's not going to help. This one here is the hypotenuse. This one here is the adjacent. Okay, so this time we're going to be using cos, which is adjacent over hypotenuse. So look at the table again. So if you look through the table, find 33 degrees, and you'll see cos is 0.839. So that means cos 33 in this triangle here would be adjacent over hypotenuse. Okay, adjacent over hypotenuse. So cos 33 is 0.839. So that's going to be equal to E over 20. So E would be 20 times 0.839, which is 16.78. I'm pretty sure. And last one, again, right angle triangle. So from the angle 14, this side here is opposite Okay, straight across from it. That's hypotenuse. We don't know it, so that's not really going to help us. And this one is adjacent. So this time we're going to use tan, which is opposite over adjacent. So next, tan 14 degrees. So we're going to look into the table and find 14 degrees. You get tan is 0.249. So we know tan 14 equals to opposite over adjacent. Tan 14 is 0.249, which will be equal to t over 22. So t is 0.249 times 22. So I need to work out what that is now. So 0.249 times 22. So 249 times 2 is 498. Put down a 0. Still have 498. Add them together. 8, 9 and 8 is 17. So 1 there. 14, 1. So that should be a 5 there. 5, 4, 7, 8. We have 3 decimal places. So 3 decimal places. 5.478. Okay, so shortly I will post some more of these for you to try. You need to do them using the table. It's annoying, I know, but it's something that you need to practice, because in an exam, well, you're not allowed to use a calculator. Okay, so you just need to practice calculating using the table. I'll post that up as well. Other than that, have a good afternoon. I'll see you all on Thursday. Bye.